The project focuses on two main areas really, and the one is environmental conservation. Obviously with the name peatland restoration is the main thing that we do, so we restore damaged peatlands in this area.
So around 80% of UK peatlands are degraded, and that's through a variety of kind of human or anthropogenic pressures essentially. So things like forestry, planting of trees on them, fire, historic drainage to increase agricultural productivity, all those kind of things together to lower the water table and with those peatlands into a degraded state essentially. So peat is really important carbon store. So I mean all that dead matter contains lots of carbon, and as it builds up through time, so it layers up around about 1 millimetre per year in most scenarios, or that's thought by that kind of layer. So as that builds up through over thousands of years, you've got this vast amount of carbon basically stored in the ground. And if it's not kept wet, then it emits carbon. Whilst it's emitting carbon, obviously that's going into the atmosphere and increasing the rate of climate change, and has an effect on that. So by re-wetting it, we're storing more carbon and keeping the carbon locked in the ground where it's currently stored. So that's got a good climate benefit, but also if we can get them to sequestering carbon again, then that helps pull carbon out of the atmosphere. The restoration really in peatlands is all about trying to raise the water table and get them as wet as you can. So to do that, it's about removing those drainage features that are installed during tree planting. So it's blocking those drainage ditches, the herringbone drainage ditches, but also removing the plough lines as well, or blocking those plough lines so that they no longer act like drainage pathways off the site to get water off the site. And you raise that water table then and retain more water on the site, bring it close to the surface, which is more natural kind of peat bog hydrology. So get more natural vegetation developing, some more species, some more sphagnum cover, things like sundew will probably increase, and then those changes will hopefully cascade through to animal species, and that's probably more longer term.
So for the core project monitoring that we do in-house, we have to focus on what we can reasonably observe within the first 5 years of the project. So that's vegetation changes and hydrological changes. For vegetation changes, we have quadrats across the site, and we measure the percentage cover of every vascular plant and bryophyte, and presence of fungi as well. For hydrological changes, we have dip wells networks across the site with automatic water level readers in them. Those automatic water level readers take hourly measurements, and then we compare them between sites and before and after works to see how the hydrological regime changes. So we have kind of regular knowledge exchange events. We're part of a national monitoring working group here in Wales where we share our best practice. We also go to conferences and we speak about what we've learned, what we've noticed on our sites and what we think that means for our sites going forward. We're also working with academic partners to bring stuff into the scientific literature where we've noticed evidence gaps and try and use some of our expertise and what we've learned to fill those gaps as we go along. Well, it's important to do all this because you want to evidence that the money you've spent has been spent well and the things that you've done on site have had a positive effect. So for us, we're working on a relatively short timescale. It was only a 4-year delivery phase, and there's only certain things that change within those 4 years. So we've used these 4 years to monitor really intensively those things where we're going to see the maximum amount of change, and set up some dedicated plots to monitor long term the things that we might expect to take longer to be noticeable.